Let's take a look at this problem from chapter 10. It's another correlation problem with a prediction. Gas prices have been volatile in recent years. The table below lists gas prices in dollars per gallon and randomly selected Connecticut stations at the time of this writing. Is there sufficient evidence to conclude that there is a linear correlation between prices of regular gas and prices of mid-grade gas? Okay. And as a follow-up, use the data to find the best predicted price for a mid-grade gas for a station that posted $2.78 as a regular. Okay, let's take a look at this. So again, we approach this by finding correlation. Is there a correlation? Is the question. So let's set up our null and alternative hypothesis when we're checking correlation. And it's based on the row being equal to 0 or not equal to 0. So being equal to 0 says there's no correlation, and being equal to 0 says there is correlation. And this is our claim as our alternative hypothesis. So a good thing to do is to punch all this information into our calculator. So I have punched that into L1 and L2 already. So these are my two lists. And then I'm going to go ahead and actually we didn't do a scatter plot last time. So let's take a quick look at a scatter plot and just show you how to do a scatter plot. If I go to second function and y equals, I'm going to get my stats plot fixed up. So in case there's any other things that are turned on, let's turn everything off first. So I'm going to select the number 4 here and then enter. So that turns all the plots off in case you have any extraneous plots that are not needed. I'm going to go to plot 1 and then I'll turn this one on. Okay, so that one's turned on. The type of plot that we're looking for is a scatter plot, and that's the first option. Select that, and our list is in L1 and L2, and then this is the mark that we want to use. Now you can use a plus or a dot, but those end up being smaller, so these little squares are the best ones to look at. Okay, now just one more thing. If we have anything that's if I press y equals to, we can take a look at to see if there's any other weird things that are happening here. So let's clear everything else out. And this is especially useful if some calculators for some reason just have some weird characters in these y variables, and it's going to attempt to graph it and it won't because it's going to give you an error. So we want to make sure that all that stuff is cleared out. Okay, now let's take a quick look at a scatter plot. So the stat plot's already set, and I'm just going to go to zoom, and instead of figuring out the window ourselves, if you scroll down you can look for zoom stat, and this is our zoom stat here. So this is our scatter plot. It looks really scattered. It doesn't look like it follows a specific line, so based on the scatter plot it looks like there probably won't be correlation. So let's get that, anticipate that answer, and then we'll take a look at it. Alright, so we've got our data in. The next step after we identified our hypotheses would be to actually run the test. So let's go to Stat, Test, and let's look for linreg t-test. So I select the linreg t-test. My data is in L1 and L2. Frequency not equal to, that's our alternative hypothesis. And if you don't have this in your reg-EQ, I highly suggest that you put that in there. So how do you find the y1? You go to vars, yvars function, and y1. So this will place the regression equation into your y1 function. So next time we graph something, it'll come up as y1. it'll draw that regression equation. Okay, so let's take a picture of this, put it in our notes. And then let's run it. So over here we're going to get 2 pages worth of stuff. Let's scroll down to get the rest of the stuff. So that's the B, S, the R squared, and R. Okay. So based on our findings, what do we have? We have our test statistic, which is a t-test. T is equal to, we got a 1.114, our p-value. I like to call it PV. That's 0.307. Let's call it 308. And our regression equation is A plus BX. So reg EQ, which by the way is stored now in our Y1. We'll take a look at that later. So our reg EQ is A, that's 1.005 or 006 plus 0.679, let's call it 68, times X. So this is your regression equation. Alright, so based on our findings, it looks like if we assume that our alpha is equal to 0.05, we see that since p-value is bigger than alpha, that's 0.3 is bigger than 0.05, we reject or fail to reject our null hypothesis. So we didn't reject our null hypothesis, that's no correlation. So it seems like there is no correlation. Seems like there is no correlation between the regular and mid-grade prices. Okay, so that's our conclusion for this part, no correlation. And again, we kind of anticipated that with the scatter plot. Now, if you hit y equals, you'll see that the equation of that line is here. So now when you go to zoom and zoom stat, I'll press just the number 9 because zoom stat is the 9th option. You can see that scatter plot along with the regression line, and you see there's a couple of points that are way off base here. So let's take a picture of this as well and put it in our, add it onto our notes here. Our scatter plot. We see that there's no correlation. Okay, now let's try to answer the next question here. Using this data, find the best predicted price for a station that posts a regular at 2.78. So by the way, our setup was a regular was our X values and our mid-grade was our Y values. So from our equation, this is the prices of our regular gas, and this is our prices of our mid-grade gas. So the ideal thing to do, if there was correlation, we use y hat. So if there was correlation, we would put in our value of $2.78 in for X, and then we would get our Y value. However, we had no correlation. So if there's no correlation, what we need to do when we make predictions is just use Y bar. This is the mean of the Y values. Okay, so how are we going to do that? We are going to take our calculator and we're just going to find the average of the Y values. So the best way to do that is say calc, and let's do a 2-bar stats, and 2-bar stats on L1 and L2. So this will give you the statistics on L1 and L2. Now we really didn't need the statistics for L1. So we could have just done a 1-bar stats on list 2. But I like to see this in L1 and L2 because I can actually see this as Y bar. And so our Y bar is this expression here. Let's put that last printout here. And let's take a look at the Y bar value that we got. So best predicted value is $2.90, 91 cents. Okay. Now this has another follow-up question. Is the result close to the actual price of $2.84 for mid-grade? So $2.84 is the actual price that this gas station must have posted for their mid-grade. You can see that it's fairly close. But since there's no correlation, it could have gone either way in this case. So in this particular scenario, this particular gas station looks like they just posted something that was really close. Okay, so that's our correlation problem and our prediction when there's no correlation. So remember that when you do a correlation test and you see that there's no correlation, you're going to use the Y bar as a predicted value for anything. So this is 278. The best predicted value is 291. Now, if somebody asks you what's the best predicted value for a posting, a regular gas posting of $2.80, it would still be your prediction would still be 291. Okay, because there's no correlation here. You can't rely on the regression equation. Okay, I hope that helps.